I am Denagamage Donarashmi Prabodha and my registration number is 2425007. I have implemented a picture matching puzzle game where users are supposed to match similar pair of images. To proceed with, this is the login register UI interface where the user should register themselves before proceeding with the game. The users have to register themselves and the users have to use the same credential used for the registration as for the login. And once you successfully log in, you will be directed to the levels interface where the level of difficulty will be divided according to beginners, intermediate, and advanced. To begin with, let's go with beginners. And once you click the button, you will be directed to the game UI where on top of the UI, the hints, attempts, and the score and the time left will be displayed, and on the bottom of the UI, the use hint button will be displayed. Once you click the use hint button, all the images will be revealed for 2 seconds and the hints will be reduced by 1 attempt. So let's begin with the game. You have to match the similar pair of images. The first click and the second clip should match with each other. Once you successfully selected the matching pair of images, you will be directed to the math game, which is the Banana API, where users are supposed to solve the equation given generated. Once you select the correct answer, you will be directed to the leaderboard with your username highlighted and the time taken to complete the task and your rank displayed. Once you click the back to levels, you will be directed to the next level, which is the intermediate. Once you clicked it, you will be directed to the next game. I have also implemented the view profile. Once you click it, your username and the score will be displayed, and you can go back and log out from the session. Now let us discuss the code segment. I have used the login class to handle the registration and the login interface. Here, it handles the registration of the users, and in this code segment, it handles the login of the players. If the username and password matches with the registration, it will be only a successful login. Let us talk about the game UI. I have divided the difficulty into easy, intermediate, and advanced into the number of attempts of hints and the time duration. For example, in easy, there will be 6 attempts of hints and the duration to complete is 120 seconds. For intermediate, it's 4 attempts and 90 seconds to complete the game. In advanced, it is 3 attempts of hints and 60 seconds to complete the game. Through the load images segment, it will randomly select images and load them into the interface through the images class. Here, it randomly selects the images and present them in the UI. This class is responsible for storing and randomly selecting images to display in the game UI. In the game UI, to handle the button clicks, I have used if the first click button is equal to the second, it will be a successful match. If not, it is not. And I have used the button use hint part to handle the use hint where all the images will be revealed for 2 seconds when the button is clicked. The banana API is used in the equation game. Now let us discuss the software principles or the architectural principles, which are low coupling, high cohesion, followed by event-driven architecture, interoperability, and virtual identity. For software architecture, low coupling and high cohesion, the game has a modular structure where each is responsible for a particular aspect. I have divided the code into three packages as code, code banana.engine, and code.database. And through the code, it will manage the GUIs, and through the code banana engine will handle the logic of the game, and through code.database, it will handle the database. For an example, for low coupling, the login class will handle user authentication and registration. The database class will operations such as storing and retrieving user data. Images class will manage random images for fetching the logic. And the game UI and the equation game will manage the games. And for high cohesion, I have used images, for instance, images to handle image related operations, ensuring the UI doesn't deal with the logic, and UI user feedback dot class to centralize pop-up messages like errors and warning, ensuring all the components follow the same feedback mechanism. And to ensure that changes in one module won't ripple the entire code base. To talk about event-driven architecture, let's proceed with a login. By handling the handle login method validates user credential and transition to the level screen on success. And I have used timeouts. As a timer event determines whether the player has successfully succeed or fails. As for the interoperability, I have used the Banana API, which retrieves random facts using Banana API through HTTP request. This allows the game to enhance user experience with dynamic content, making it more engaging. Also, in the database, I have used hashing by decoupling the game logic from database implementation. We ensure the system remains adaptable to future changes. As for the virtual identity, the game manages virtual identity through username and passwords. Here's how it is done. Through secure storage with password hashing. Passwords. This makes it impossible to retrieve an original password. And the sessions will be managed through the session class. In conclusion, the modular structure of the game ensures low coupling and high cohesion, making it maintainable and scalable. The event-driven architecture makes it interactive and responsive to users by using timers, event trigger buttons. The game achieves interoperability by using the Banana API, and virtual identities securely managed through the password hashing and session based authentication. Thank you.